I think sometimes when you hit stop and start really quick, it doesn't register both clicks. So I did a whole bunch of stuff and it wasn't recorded. So sorry. I'm just gonna keep on going. And I'll try not to screw that up again, but I don't know. Something about I just gotta pay attention when I click on OBS to if I like stop and start recording right away, it it doesn't register for some reason. So I need to stop recording, start timer, and then start recording again. So there's a little bit of a delay between those button clicks. Okay. So anyways, we are going to put the references to the we're going to finish the wiring up of the loop table container, and this generic global initializer that runs after the basic setups are done, because what we're about to do requires that both the data and the functions exist at the same time, but it's not really initializing classes as far as I'm concerned. So I'm going to just put it in here in this initialization routine. And we're just assume that this initializer that's numbered 0 means that its only dependencies are these guys here, and then if I have to put something down here, then it means that the dependencies include this function and then this, right? So, and then if we have even more dependencies stacked, we'll just keep on numbering more functions. So we won't be doing any dependency injection. We'll just be like very conscientious of what our dependencies are. So we have the native window, the global objects, and the rendering logic, right? And if we take a look at the initializer for the global data, we can see we have the loop table and the loop table, right? Those are just directly on there. Yeah, they're directly on there like that. So, okay, so we'll just take this and we can just throw these together like that. So it's going to be global data, and then the loop table, and then these different function pointers. And we can just assign them to each other. And if we wanted to, we could technically I feel like things might get a little bit spaghetti-ish if we put these functions directly into our function container. You know, yeah. Oh, we already did it with the. Yeah, I don't know. I'm questioning whether or not we need the function container or not. That's just more writing for no extra added benefit. It's just a layer of indirection. Does it really accomplish anything? Well, it does help centralize, kind of like, I don't know. I'm not sure. Well, we can just try it. We'll learn from it, I guess. I'm not really sure if we should. So global data, and so what I'm saying is that we could take these guys and we could we could have like the global functions dot we could do like we could do like this, right? We could have something like that and then set those equal to that. Right, and then over here we would the global the global data needs access to the functions, and that's why we're down here. And then we do like global functions, and then we just can access the loop table functions, right? And then right, and that's like, I don't know, that's kind of like some very convoluted indirection. It's like, why did we convolutedly do that? Uh, um, let me think. I kind of get what, I don't know. Right, because now there's the potential to like accidentally transpose these, because the more times we shuffle them around, there's the more times that we could accidentally transpose them. So I'm not 100% on this or not. I kind of get it. I kind of get why I'm doing it. Kind of shows me that there's this dependency between this data and these functions, and because of that, it has to be done here to wire it up correctly rather than in one of these objects. So I think it helps communicate something, but I'm not certain. I think it because of the way things would have to be done in the C code, where all the functions would have to be directly after the data. Or no, all the functions would have to, yeah, all the functions would be directly after the data. Right, because the functions operate on the data, so the data is first. And so the data for the loop table would not be able to reference the functions right away, so you would have to do that. Okay, yeah, I don't know. I guess I'll keep it like this. So global data, global functions, the native window, game objects, and the render logic. And then we'll just go add those functions to the global function container initialization. So right down here, so we have this loop table equals new loop table. Oh, okay, hold on. So if we're... Oh, no. That was not right. Global functions, right? Because otherwise we could just populate it in there. So what I'm saying is we're going to take this. We got the loop table tick. And then these are also loop table tick. We could do that. We could go loop table tick natwin, right, like that. Actually, we should give them the exact so down here we're gonna call them that. Okay, so these are we can make them all capital because they're kind of like, they're function pointers, but they're constant. Loop table tick. I don't know. Alright, so this is loop table tick. And then these are like the sub functions. Yeah, I'm not sold on what I'm doing here. But we gotta try our best to have some type of sensible reason for why we're doing things. But we can't stall forever. Like, we can't just sit here and think about it forever. Eventually we gotta write something. What's that saying? Like, the wrong answer too late. The right answer too late is the wrong answer, right? Native window, global object, render logic, right? And so we have that, and then when we're wiring that up, we want to call these like all capital ones, right? And so when we call these initializers, we're gonna reference these. So if we go over here into our initializer for where did we call it? So where we're initializing this stuff, we're not going to call it like that. We're going to say like and we want to line stuff up a little bit. Yeah, that's going to look ugly. It's better to look ugly than accidentally. Global data.looptable.native window, global function.looptable tick, native window, sure, why not? And then we'll just copy paste, and we'll just do the same thing for the game objects and render logic. Oh. Render logic. Okay, so we got our native window, our game objects, our render logic, and then these are all different, and these are okay. So that's all good there. I'm just gonna make a little comment that on this where it's like this is ugly, possibly overly convoluted. This is ugly and possibly overly convoluted. I am not sure. Let's just keep it this way, and we will know if it is overly convoluted once we transcribe it to C11 code. So yeah, so I don't know. I'm uncertain about this. It seems convoluted because we're like juggling around those function pointers like way more than they need to be juggled around. Like we're passing them all over the place, right? So global data.looptable. So we're setting up the loop table object with the non-default function pointers, and we're taking them from like. So let's see, this is one, so here's an assignment. So every time we have an assignment, we're going to count that as an indirection. So you got this equals, that's one level of indirection. Let's go over here. And so then we assign this here. That's 2 levels of indirection. And let's go over here and find this guy. Okay, so 2 levels of indirection. 2 levels of indirection when I think there should only be 1, basically, right? But that's not too bad. I mean, it's just slightly more excessive than than I think it should be, but let's just take a look at that, see if that is actually working. So we screwed something up. Let's look at the console. A2JS loop table tick global object is not glow obj. Why did I call it that? Because it should be game objects, right? So I'm gonna go open this. native wind, game objects, and render logic. So, yeah, so that should be game objects. So this should be game objects, and then this also should be game objects, not global objects. Okay, and then we're gonna have to make sure that that's referenced correctly. So that's still referenced correctly, so that's right. Okay, so let's take another look at the code, make sure that it's running correctly now. And we have the texture showing up, and we don't have any errors. So I'd say we have the framework for having updates going on. And actually what we can do is we can find our GL draw arrays now. GL draw arrays. And where are you? That was GL. Okay, so if I uncheck match case. Oh, sorry, because this is not C code, it's just draw arrays. It's like GL dot draw arrays. I'm pretty sure we can just take this draw arrays call and we can put that into our render loop. So this is our render logic. And then okay, so now that we've put that in there, let's hope that the shader code kind of like updates and we see something different. Because I'm expecting that texture size fetch to influence what the shader looks like. So now if we go here and we refresh, no dice. Reference, GL is not defined. Yeah, that's right, because we have like all these different containers set up. And that's not how we're going to do it, right? So we're going to do it like, so if we go into here, right, because we just ripped that out of there without thinking, but it's going to be the adapter, I guess, was a global class, I believe. So if we look at our global classes container, I believe the graphics adapter was part of that. So if we look, let's go init global classes. And in there, we can see our adapter graphics is part of that. So global classes.adapter graphics. So right here, it's going to be global classes.adapter graphics. And then we know that we're going to have our actual OpenGL context. And for that, it's going to be context graphics. And then, and only then, after all of that, do we call draw arrays. So if we have all that correctly, that is, I gotta say, this is kind of hard to read like that. Now, do we want to keep the dots like this? Well, the dots after make it a little bit, make it easier to line up, that's for sure. You could do it more like this. I don't know. Indent that a little bit more. Whatever. Let's not worry about it too much. So, refresh, and we still got a problem. Oh, gl.triangle fan. So let's cache this. So let's say, var and then a context graphics. Now, if this were, yeah, so let's just say var context graphics equals global classes dot adapter graphics dot the actual internal context graphics, so the implementation specific, implementation specific, and then we'll just do that. So this is just shorthand. So now you can just rip that off. We're going to rip that off. And now we can take that as well, and we can put that right there. Okay, let's take a look, see if we are onto something yet. And well, we got a white screen, so that's okay. Let's go look at our shader code. And well, first let's comment this all out. We're gonna comment everything out in the body. And then I'm going to refresh. Okay, so definitely it's the shader code is doing that. But is it... But why that? I think I might have set everything to white in the shader code. So let's see if we can try to get some better feedback besides white. Because the white feedback is the exact same feedback as we get when we totally crash the program. So it is not helpful feedback. So in here, we actually do have, looks like we commented out some code, right? Because we have RGB. This would make white feedback. That's for sure. And it looks like we commented out this part. So if we put this back in, hopefully we'll notice something. I'm going to refresh really quick. And then I think I may have, did I... Well, let's see, let's remove some breakpoints. Red, green, and blue, and then... Oh, because we're not setting the fragment, ever. We're just not doing it. So why don't we... Okay, yeah, let's do that. So obviously it's not going to work if we don't have a point at which we actually set the... I didn't know that the default would be white. I think that's because I might have set my GL clear color to white, so maybe that's why we have white as the default when nothing is showing up. But we can do vec4, and we can do R, G, B, and A. Alright, so this is our fragment variable. This is our fragment variable right here, and we just need to make sure that no matter which branch we take, we're going to set it. And let's have some other type of default besides white, because that'll throw me off. So I'm going to say the default will be like a gray. Sure. Why? Now let's keep it like mostly opaque for the alpha. And so making it more opaque is going to make it a little bit lighter of a gray. But yeah, think a gray for the default rather than a white will help. And then if that texture is actually within the bounds of if the texel on the screen chord is actually within the bounds of the size of the texture, we're going to just paint green. And then once we get the proper feedback we're looking for, then we can start doing like a Textile Fetch. So let's refresh this, see what we got. And I am not impressed right now. I am not a happy camper. Compile shader failure. Oh boy. Okay, so wrong operand types. That takes int. Okay, so I'm mixing floats and ints. Right. Really? As though... Okay, where the hell are they mixing floats and integers? Oh, is it the frag chord X and the... yeah, well, why don't we look up what the type of GL So we're gonna look up the type of GL frag chord, because maybe GL frag chord is a float value. Oh, what is the range? That might help. What is the range of GL frag chord? Because if I see a range that says, like, is this an integer? What the hell is this? GL frag chord assumes a lower left origin for the window coordinate and assumes pixel centers are located at half pixel coordinates. For example, the XY location, x 0.5, 0.5 is returned for the lower leftmost pixel in a window. Pay attention to pixel centers concept. Alright. So we need to make sure that when we're trying to do the Textile Fetch that we're not mixing up our coordinate systems, because that looks like what we're doing. And I'm not... We're pretty close. It's just, if we look at the Textile Fetch, IVEC2 position. So yeah, so... Textile Fetch WebGL2 example. Okay, so Control F, Textile Fetch. Let's see, Textile Fetch. So that takes an integer and coordinate. IVEC2 text chord. Okay, yeah, so I believe you gotta turn it into a integer vector first. VST times size. Is that the, like, S and T coordinates? Okay, size. Vec2, okay, so the texture coordinate, it looks like texture size. It looks like you have to normalize the coordinates before this is going to work, right? Because the frag chord is going to be, or do we need the texture chord? Well, frag chord is the output, I think. Oh boy. Yeah, frag chord is the output, so I believe we need the that I'm looking at frag chord when I should be using the texture chord. And the texture chord is like an input in frag color. Okay, yeah, I don't know. I have a good idea. I need to take a break really quick, but I'll be back.